Module 8, Lesson 1 covers proportional relationships and slope. And slope is a really huge concept that you're going to be using a lot as you get into Algebra 1 next year. The suggested pacing claims this is going to be a 90-minute lesson, which I can totally see slope being a couple-day lesson. We've got 20 resources to dig through. Let's get started. The Arches National Park and Bryce Canyon National Park are both located in Utah. Each park charges an entrance fee that is valid for 7 days. The entrance fee at Arches National Park is $25 per vehicle. The entrance fee at Bryce Canyon National Park is represented by the equation y equals 30 times x, where y is the total cost and x represents the number of vehicles. How can you determine which park has the greater cost per vehicle? These are the kind of things we're going to be working on as we get into this lesson. Our inquiry question asks, how can you describe how one quantity changes in relation to another quantity? We're going to describe it as we have a lot of terms. You can call it the slope. You can call it the rate of change. You can also call it the constant of variation. There's a lot of different terms to represent this. An example of this would be if Marcus downloads 2 songs for every 1 minute of internet. That means he has a lot faster internet than I have at home. From there, we can have in 0 minutes, he does 0 songs. 1 minute, he does 2 songs. 2 minutes, he does 4 songs. Whoops, I'm missing my numbers here. 2, 4. 3 minutes, he's going to do 6 songs. And 4 minutes, he's going to be doing 8 songs there. Now we can take and represent that data on a graph. So we're going to take and start plotting points. Of course, 0, 0 is just going to be right there. And then the next point is 1, 2. Remember that Superman runs and then he flies. And then we have point 3, 4, 2, 4. Superman runs 2, flies 4. And then at 3, 6, Superman runs 3 and flies 6. And then finally at 4, 8, Superman runs 4 and flies 8. And what do you see when we do this? What I see is a line. Yeah, pretend that's really a straight line there. We have created a linear equation to represent the value, or a linear representation to represent the value. Because it creates a line, we can say that there is a constant rate of change, or a direct variation, or a slope. And that slope is always going to be the same, where we rise 2 and run 1, so the slope is going to be 2. But I'm getting ahead of myself. We'll talk more about how we find that slope later. And it looks like later is now. We zoom in here. We want to take and drag the number of ways he can, the ratio here. So he has the songs, the change in songs. He gets 2 songs for every 1 minute. This is also known as a change in y over the change in x. This is also known as rise over run. We'll talk more about all those later. So you have 2 over 1, otherwise known as 2. So the slope, or the rate of change, is going to be 2. 2 quantities are going to be proportional if they vary and have a constant ratio, otherwise known as a unit rate. So we can take and highlight that. That's going to be a unit rate there. No, that really doesn't define unit rate, but that's okay. A unit rate is 2 ratios that compares to 1 unit, miles per 1 hour, home runs per ball game. It has to compare to 1 to be a unit rate. The graph of proportional relationship is a straight line through the origin. Relationships that have a straight line graph are called linear relationships, and you heard me use that term earlier. So, in words, a linear relationship is a proportional when the ratio of x to y is going to be a constant m, and you're going to find we always use m for slope. Nobody knows for sure why. They think it's because of some dead French guy who referenced it in a book a few hundred years ago and called it the modius of slope or something like that. And then we have the table. You can see you have a constant rate of change, where for each increase of 1 in the x values, you get an increase of 3 in your y values, giving you a constant rate of change. In symbols, we would say that slope is equal to y divided by x. Of course, but it's also be written as y is equal to the slope m times x, where m is going to be a unit rate and m is not going to be equal to 0. And finally, in a graph, you can see a linear expression makes a straight line. Picking up a few more definitions here, an equation such as y equals 3x is called a linear equation, and a linear equation is defined as an equation with a graph that is going to be a straight line. Another vocab word. Notice, whoops, didn't mean to cover all that stuff. Let's clear that out again. Try it again. And that's better. Notice that that this equation contains more than one variable. You have both a y and an x here, two variables, and the solution to a linear equation consists of two numbers, one for each variable. You can have a number for x and you're going to have a number for y. Our next definition is going to be a rate of change, which is defined as a rate that describes how one quantity changes in relation to another quantity. In a linear relationship, the rate of change between two quantities are going to be the same or constant, and this is known as a constant rate of change. All right. The time to download songs is shown on the table here. Notice that you get the same number of songs increases by 2, and the time in minutes increases by 1. So you have a constant rate of change going on here. For every 1 minute, you gain 2 songs. A constant rate of change. Another term we get is slope, and slope is, quite frankly, another term for rate of change. In proportional relationships, the unit rate is going to be the slope, and the slope is going to be the rate of change between any 2 points on the line. Now we're going to move through some slides here to figure out how this one works. So we've got the same graph we looked at earlier, the same one we drew out, and we can see that every time the minutes increase by 1, the number of songs increase by 2. Now watch what's happening down here on the graph when I do that. When I go up again, what do you see? You have a rise of 2 for a run of 1, a rise of 2 for a run of 1, and a rise of 2 for a run of 1. And this is what is going to be known as the slope. You can see down here that they took the change in songs. We discussed this earlier over the change in minutes. They picked any 2 points. Doesn't matter what 2 points you pick, you're always going to get the same answer. So they had 0.12 and 0.24. This 4 minus, let's see if I can highlight these. So the 4 minus that 2, let's make it yellow. And then right here, actually I should have made those green because they're green of the things. Let's make those green here. And then the other one, you've got the 2 minus the 1 right here. So your y terms are being subtracted on top, which gave you 2. Your x terms are being subtracted on bottom, which gave you 1. That gives you a slope or a rate of change of 2 over 1, also known as 2. For example 1, they tell us that the graph shows the amount of money Ava saved over the course of several weeks. And you can see it made a straight line. Since it made a straight line, you're going to have a constant rate of change going on. Find and interpret the slope, then find the unit rate that compares it to the slope. So let's take a look at what they're going to have us doing here. We're going to take and end up subtracting any 2 points, and they chose this point and that point. It does not matter which 2 points you pick. Pick any 2 points along that graph, it's going to simplify down to be the same answer. So the rises are going to be the change in y. So you have 30 and 15, and you can see right there you get 30 minus 15. And then the runs are going to be your change in x, which is going to be 2 and 1. So you have 2 minus 1, which is equal to 1. So your slope is going to be $15 for every 1 week. That's also going to be known as your rate of change, and it's also going to be known as your constant of variation. So the rate of change is going to be $15 per week. The slope is 15 over 1, or 15, and that means that Ava saves $15 every week. Now it's going to be your turn. Do extra example number 1 on your own to find out with a graph to explore the graph that shows the distance William walked over the source of various hours. How'd you do? Let's take a look at what I'm going to get here. First off, I notice it is linear. It makes a straight line. Because it makes a straight line, it means I have a constant rate of change. And remember, the rate of change is also going to be known as the slope. From here, we're going to pick any 2 points, so I'm going to make it simple. I'm going to pick that point and that point. And the formula I'm going to use is a variation of what they've been using. It says the change in y divided by the change in x. So my y values here are going to be a 6 and a 3. So I have 6 minus 3. My x values here are going to be a 2 and a 1. So I do 2 minus 1. From there, I'm going to simplify. 6 minus 3 is 3. 2 minus 1 is 1. So the slope is going to be 3 over 1, also known as 3. Jump back over here to our textbook, and so when we take and find the slope is going to be, they want it as a fraction, so we're going to take and put in the 3 over 1. There'll be a point in your life where you just get to put down 3, except, and that means he walked 3 miles per hour. Very good. The unit rate is going to be 3 miles per 1 hour, which is the same as the slope of the line. Check, and that checks as well. Easy math. Now in example 2, we say that the distance y in miles a certain cyclist can ride and a time x in hours is a proportional relationship. That means that that cyclist rode the same exact speed every single time. Every hour they were traveling the same number of miles per hour. The equation that they have here is y is equal to 12x. And what they want us to do is actually apply this for 0, 1, and 2 miles. So you can see at hours, my bad, at 0 hours, 12 times 0 means they didn't go anywhere. That cyclist was stationary, 0 miles. In 1 hour, 1 times 12 gave 12 miles. In 2 hours, 2 times 12 gave 24 miles. From there, we can graph those ordered pairs. So let's zoom down just a little bit and I'll start selecting some points. I've got point 1 is going to be at 0, 0. Point 2, Superman runs 1 and he flies 12. And point 3, Superman runs 2 and he flies 24. And then we can connect those points with a line. So my line's going to start there. It's going to keep going right up through here throughout all time and eternity, as long as that cyclist can keep pedaling anyhow. That's going to be our graph. We'll check that. That checks correct. And now from here, what can we learn from this? We can say in the equation of a proportional relationship, the equation format is y equals m times x. Your m value represents the slope of the line. Okay, that's important. So the equation y equals 12x, the distance y in miles, and the cyclist can ride in x hours. Your slope of your line, your m value, is going to be 12 over 1, also known as 12. That means the cyclist can ride 12 miles in 1 hour. It's your turn again. Work extra example number 2, which talks about a grocery store having oranges on sale. So, the grocery store is having a sale on oranges. The cost y in dollars of oranges and the number of oranges x are proportional relationship. The situation can be represented by y is equal to 1/3 x. Now I want to point out that 1/3 is a fraction, and for me doing this, I would be picking values for x so that I can get whole number answers for both x and y. So let's see here, since it's going to be a dashed line because we cannot use half an orange. So from here, graphing the equation, well, we need to pick up some values here, don't we? So let's go over to our scratch page, and we know that our formula is going to be y is equal to 1/3 times x, where x is our number of oranges. So I'm going to do y is equal to 1/3 times 0, which means he gets 0. I'm going to do y is equal to 1/3 times 3, otherwise known as 3 over 1. And those simplify, which means y is going to equal to, not y is going to equal to 1. And then I'm going to do one more that says y is going to equal to 1/3 times 6. And I chose 6 because it'll simplify as well. And when I multiply that out, I get 2 over 1, otherwise known as 2. So my ordered pairs here are going to be 0.00. It's going to be 0.31. And it's going to be 0.62. Those are the three ordered pairs I'm working with. Jumping back over here to our problem, I'm going to put a point in at 0.00. Apparently, I don't know how it's supposed to let me put a dot in, but we're going to start at 0.00. Oh, there we go. And we're going to put another one. It's going to be at 31, which is going to be there, and then you're going to have 6.2, and so on. Check our answer, and the answer checks. That's going to be the graph of the line. Moving down from there, the slope of the line is going to end up being, what did I say? It's going to be 3, make that a fraction. For every rise of 1, you run a 3, so the slope is going to be that 1/3 that we had, the m value that was in our equation, and that means that the cost per orange is going to be about 33 cents, because it's 1/3 of a dollar for each orange you end up buying. That's going to be it for video 1. Come back and watch video 2, where we continue the study of slope.